How's it going, y'all? And welcome back to another video. In this video, we're going to be talking about attributes of functions. And before we talk about attributes in the math sense, we're going to talk about how you might use it in your daily lives. So if we're talking about attributes with someone's face, just an example of this face, is some things that we kind of pick out. Attributes are things that you kind of stand out to you, like their circle eyes, the triangle nose, or the rectangle mouth, or the triangle teeth. And what we can do with these attributes that we kind of picked out is they're identifiable points. They're points that we can kind of reference and go back to. So now we're going to talk about attributes in the math sense. So these are kind of identifiable points that we look for in all different types of graphs. So the first two are x and y intercept. Now they're very, very similar. The only difference is where they cross. And hopefully when you hear the word intercept, you think of crossing paths or crossing over, because that's exactly what's happening here. So if we look at the y-intercept, it's where the graph crosses the y-axis. Now remember, your y-axis is going up and down. It's that black bolded reference line. And then same thing with the x-intercept. The x-intercept is where the graph crosses paths with the x-axis. And remember, the x-axis runs horizontally side to side. Now the last one we have here, and we do have a couple more after this, is the vertex. Now you can think of the vertex as the turning point. So it's kind of where the graph turns and changes direction. So I go from decreasing or going down to turning to where I'm increasing and going up. Now our last two types of attributes that we're going to be looking for is minimums and maximums. Now with your minimum, that's your absolute lowest point, and it has to be a physical point. So think of it kind of like a valley where it kind of bottoms out. And the minimum most of the time will be that vertex. Now with maximums, that's the highest point possible. So you see how it's pointed up to the top. So if the graph stopped right there, that would be the maximum value, the highest value of this graph. Now the last piece that we're going to talk about with the minimums and the maximums is something called an absolute maximum or an absolute minimum. Now with those two, with that word in front of it, absolute, means that it's the absolute highest or the absolute lowest. And that's a brief overview of a few of the attributes that will be using in Algebra 2. Hope to see you back for the next video where we're going to be doing a few practice problems where we label the attributes of certain functions. See you then. So in this part, we're going to be practicing finding the attributes of certain equations and graphs. For this first problem, I split it up into three, so it's the same problem. So for the first section, it's domain and range. The second section, it's x and y intercepts. And for the last section, we either have the vertex or the maximum or minimums. So for the first section, if we're looking for domain, remember that's always going to be the x values. We'll write that over here, x values. And then remember, range is always going to be the y values. So if we're trying to find the domain, and remember we can use interval notation, we could use set notation, or we could use inequalities. What I'm going to use for this one is I'm going to use interval notation. So for this part, we're looking to find the lowest x values. So we're going to follow along the graph to see which part of it gets the most negative, because that'll be the lowest x value. And so it looks like right here, and now since it's already touching the x-axis, we don't have to draw a line or figure out where it's going to be heading towards or what value that's going to be touching. So part of our job is already done for us. So we say the lowest x value is -5. Now we're going to follow along the graph to the right to see which part of the graph gets the most right. And it looks like this point right here is probably the furthest right or the biggest x value. Now it's not touching the x-axis, so what we're going to have to do is we're going to have to draw a line to the x-axis to see what x value this is right here. And now if we count along, so we see 5 and it goes by 1, so 6, 7. So our highest x value is going to be 7. Now, whether or not we use the brackets or the parentheses, we're going to check our table. If you remember from last video, we had that table where it says, does it include the number or does it not include the number? So since we're using, if we look back, we have these filled dots, so the solid dots. And if we have a solid dot, we're going to be using the bracket. Now, since the solid dot is on both sides, both at -5 and at 7, we're going to use the bracket for both. So now we're going to talk about the range. So we're looking for the lowest y value and the highest y value. We're going to remember with range, it's the y values. So we're going to highlight the y-axis in just a second, so we know what to be looking for. So we have our y-axis right here. And so if we're looking for the lowest y value, we're just going to follow along the graph to see where it lands, and it looks right about here is probably the lowest point for the y value. So remember, up and down. Now, since it's not touching the graph, what we're going to do is draw a line to the y-axis to see what the y value might be. And if we take it away, it looks like if we started at 0 and we went down 1, the lowest y value is going to be -1. And for this one, we're going to do interval notation as well. So now we're going to look at the highest y value, so we'll follow along the graph. It could potentially be right here or here, where I've labeled this little point already. But it looks like the furthest left or furthest right point is going to be our highest y value. And since it's not touching the y-axis, what we'll do is we'll draw a line over to it to see what our y value is. And it looks like if we count up, or we can start right at 5, we go up 1, that's 6. And then from here, we need to figure out whether or not we need to use the brackets or the parentheses. We have 2 solid dots, both in the lowest and the highest point. So we'll go down, we'll say, hey, lowest or solid dot means we put a bracket on both. Now that we've gotten the domain and the range down, we'll slide over to the x and y intercepts. Now a quick review of x and y intercepts. Remember, that's where, for the y-intercept, it's where it crosses the y-axis. The x-intercept is where it crosses the x-axis. So if we're looking at the y-intercept first, we're looking for where it crosses the y-axis. So we're looking for when it crosses the y-axis, and it looks like right here is a nice spot. So if we wanted to find that ordered pair, since we didn't move anything to the left or right, we didn't go up or down anything, the y-intercept will be at 0, 0. So now we're looking for the x-intercepts. That's now where it crosses the x-axis. So we'll highlight the x-axis. And it looks like we have a few points where it crosses or touches it. It looks like our y-intercept is also an x-intercept. We have one right here, and then we also have one right there. Now we'll just go from left to right. So the ordered pair for this touching point, this crossing point, if we start at 0, 0, we'll move over 1, 2, 3, 4, 5. So our x value is -5, and we didn't go up or down anything, so our y value is going to be 0. And now I'm just going to draw up here just as a reference, make sure we know for ordered pairs it's always x, then y. So now we have our x-intercept also at 0, 0. Same thing with the y-intercept. An x-intercept could also be a y-intercept, depending on where it is. Usually it's only going to be at 0, 0. And then for our last one, the furthest right, we start at 0, 0. That's our starting point, and we move over 5. So 1, 2, 3, 4, 5. So our x value is going to be 5. And then since we didn't go up or down anything, it's going to be 0. So we have our x and y intercepts. We'll go to the last section. Now, for this specific question, this won't have a vertex. Now, we will talk about a problem that will have a vertex for our next example, but this problem does have a maximum and minimum. Now, if you remember with maximum and minimum, maximum is the absolute highest value, and then minimum would be the lowest value. So it looks like we're experiencing a little technical difficulties. We'll see you right back, hopefully in a second. Well, that's better. So we're going to finish out this problem. We have our maximum minimum. So remember, maximum is the highest value, highest point of the graph, and minimum is always the lowest point of the graph. And we're usually only looking at highest and lowest as it relates to the y-axis. So if we're going to look for the maximum first, we're just looking for the tallest point, and for what it looks like, just looking at the graph and eyeballing, that'll be our maximum. And then our minimum, we're looking for the lowest point. It looks like, according to the y-axis, this will be our lowest point, our minimum. And so now we're going to take our ordered pairs from it. So if we look at our maximum, we'll count over 1, 2, 3, 4, 5, 6, 7. So if we're going to make our ordered pair, the x value will be 7. We counted over 7 to the right. And then we're going to count 1, 2, 3, 4, 5, 6 up. So our maximum is 7, 6. Sometimes you'll just see it as y equals 6. And then for our minimum, we'll count over, start at 0, 0, 1, 2, 3, 4. So we went to the right 4. And then instead of going up, we're going to go down 1. So since we went down 1, that's where the negative numbers are. We get 4, negative 1. Sometimes you might see it as this right here. And just a quick reminder with when getting points from the coordinate plane, remember all the points that are going to be in this coordinate. So if we have the x and y, we'll have positive values for both x and y right here. In this quadrant, we'll have negative numbers for x and positive numbers for y. And this is quadrant 2. This is quadrant 1. Quadrant 2. Quadrant 3. Quadrant 4. We do use Roman numerals for this. And then in this quadrant, both the x and the y are going to be negative. And then our last one, we'll adjust this. We're going to have a positive x value, but a negative y value since we are going to go down. So I hope this helped with the attributes. I'll see you in the next part for the last example. So this is going to be our next example of finding all the attributes. And just like with the last one, I split it up into 3 sections: domain and range, x and y intercepts, and vertex minimum maximum. Now with this domain and range, it's a little bit different just because we have these arrows at the end of our graph, both ends actually. And what that means is that the graph, if I gave it enough time, the graph would keep going. So if I had a big enough piece of paper, I would be able to keep graphing this. Now, if I look at the left hand, so remember with domain is always going to be our x values. So I'm going to highlight our x-axis. And now if we look at the left-hand side, because that's where our smallest x value is, if I let this graph keep going, it would keep going and going and going to the left. The numbers would keep getting more and more negative. And what it would approach, and you might remember this from Algebra 1 or geometry, but it's going to approach negative infinity if I gave it enough time and the graph keeps going to the left. Now, if I look at the right-hand side of the graph and I see, okay, well, how big possibly could this, like how big could the numbers actually get to? And remember, we're only looking at the numbers going side to side. Now, if I let it keep going to the right, if I had a big enough piece of paper, yes, this graph would go up, but it would also go to the right as well, and if I gave it enough time. And so if I gave it enough time, if we had hours and hours and days, it would eventually get so big and it would approach infinity. Now, if we look at our whether to put the brackets or parentheses around it, we can never actually get to infinity. Infinity isn't an actual number per se, it's more of a concept. And since it's more of a concept and it's just something we can get close to, we can't include that number using a bracket. We have to use a parenthesis. Now with the range of this graph, remember that's our y values, that's going up and down. So we'll highlight our y values. So we'll look for the lowest part of this graph first. So we'll follow along the graph and it looks like it's right about here. And now what we'll do is draw a line over from that point to the y-axis to figure out what our lowest y value is. And if we look at it, it's -1. So now we're going to look at the highest y value. So we're going to see how tall does this graph get? How big does this graph get? And if we follow it up, remember these arrows mean that it would keep going. And if we gave it enough time, it would get to infinity. And so that's why we would put infinity. And since the numbers are getting bigger going upwards in the positive direction, it's positive infinity. And just like with before, we're always going to put a parenthesis around our infinities, either one, negative or positive. And then since this point isn't a hollow dot, it's included. So since that number is included, we're going to put our bracket around -1. So now that we have domain and range, we'll scooch over. We'll go to our x and y intercepts. So what I'll do is I'll highlight our x and our y so we know what we're looking for. So we'll look at y-intercept first since that's our first one on the list. So we're looking for where it crosses the y-axis. So we're looking for where does it cross that highlighted. And it looks like right about here is where it crosses once. And if we needed to get that point, remember it's always x, y. Now x value, we didn't go to the right or left anything, so that's going to stay 0. And now we're going to say, okay, well, what is our y change? What's our y value? And then we're going to go up 1, 2, 3 to get to that point. So our y-intercept would be 0, 3. So now we'll look at the x-intercept. Do we have any x-intercepts? It looks like we have 2 of them right here, right there. So for the first one, our y value is 1. We went over 1, and we didn't go up or down anything, so that's going to be 0. And then we'll count over 1, 2, 3. And same thing for this one. We don't go up or down anything. We stay along the x-axis, so the value is 0. So there's our y-intercept and our 2 x-intercepts. Now for our last section, this equation will have a vertex since it's a quadratic equation. So the vertex is always going to be the turning point. It's where the graph changes from decreasing to increasing. You can think of it going down to up to down, but it's always going to be the turning point or the axis of symmetry, which we'll talk about in a little bit. So our vertex, we're gonna name off the point. So we're gonna start at 0, 0, and we count over 2. So we know that Our x value is 2 to get to it. And then instead of going up 1, we're going to go down 1. So going down 1, that's negative 1. So our vertex is going to be 2, comma, negative 1. Now we're going to try to figure out whether we have a maximum or minimum. Maximum is the highest value, and minimum is the lowest. Now if we look at this one, it looks like it bottoms out. And so if it bottoms out, there's always going to be a low point. And so what's going to happen is our vertex is either going to be a minimum or a maximum. And so if we look at it, we say, okay, well that bottoms out, so that's the absolute lowest this graph gets. Because if we said we tried to figure out if there was a maximum, this graph would keep going up. So there's really not a point that we could say that's the highest the graph gets, because it's always increasing. So for the maximum, there isn't a maximum, but there is a minimum, and the minimum is that point, or you could say y equals negative 1. And I hoped that helped with looking at our attributes, all of our different ones that we're going to solve for. So I hope that helped, and see you guys in the next video. See ya.